Alright, chapter 6 is cost behavior. This chapter requires a little bit math skill. One math skill is geometry. It's an analytic geometry. You need to understand the coordinates, and then I need to understand how to calculate slope. Then there will be a little bit of algebra. So we have equations, but it's very simple and very basic. So hopefully this won't be any difficult to you as a student. All right, this chapter is on the cost. We're going to focus on another way to categorize the cost. It's called variable costs and fixed costs. So let's take a look. It's not moving. Okay. First objective is to describe key characteristics in a graphs of various cost behavior. So cost behavior means how costs change as volume changes. So if there's no other costs, assume that you're making chairs. And let's assume you're making chairs from the wood. So you're going to process the wood to make the shapes and put them together. Let's assume they have 2 or 3 different processes. And when you finish all of these, you find, okay, for each chair, and you're going to spend $5 as the cost. So you can say it as 10 or 20 or whatever amount as the price. But assume your cost for each one is $5. Okay, so unit cost is $5, but the total cost. So if you have 20 chairs, the cost will be 20 times 5 will be 100. If it's 100 chairs, it will be 100 times 5 or 500. So the cost grows as the volume changes. So this is kind of the cost behavior we're looking at here. So there are 3 different common cost behaviors. One's called variable cost, one's called fixed cost, and one's called mixed cost. So actually there's another one's average cost. So that's what we're going to total cost and average cost we're going to take a look. Mainly, I think, mainly it's the total cost we're going to take a look here. Total cost is the total of a variable cost and a fixed cost. It's also the mixed cost. So there'll be different names for the mixed cost or the total cost. So we're going to look into this in more details. So some characteristics of variable cost. Total variable costs change in direct proportion to changes in volume. So variable cost per unit remains constant. So let's say the $5 a chair is a cost, variable cost, so it doesn't change this number at all, but only when the volume goes up, the total variable cost changes. So basically, this variable cost per unit is the slope of the, you have we talk about the geometry, right? And the leg geometry, we have a coordinates x, y, x axle and a y axle, and so you can find the slope of a line. So we're going to take a look here. So vertical y-axis is always shows the total cost. So vertical is always total cost. Vertical is always total cost. Horizontal, it shows the volume of activities. So it depends on what name you give to. The company has tried to categorize the cost. So this will be total cost of something, and then this is volume. Here is the thousands of guests. So here, this is a little bit small here. The $3 per guest. Those will be variable cost, and so when you grow the volume, the number of guests, and you're going to have a total cost increase at the same time, because we have a constant of customers or guests. That means we're going to have a straight line. So it's very simple, and it's a straight line. And for the straight line, it's easy. We can find a slope. Slope is this one divided by this one. The same thing for this line. This is a little bit steep, so slope will be y divided by x. So here it starts from the original point, and we may also have a line starts from here, gets over here. Then if that's the case, then we're going to see the slope will be delta y divided by delta x if it's not 0 here. So we're going to see that a little bit later. So we're going to use cost equation to express and predict costs. Cost equation, very simple. Y equals to variable, it's actually V, variable cost per unit times X. So here, oh yeah, here's the other one. So total variable cost equals to variable cost per unit of activity times volume of activity. So Y equals to V times X. So this is a arithmetical equation for straight line. So it's straight line. There's only two variables, independent variable, dependent variable here. So Y equals to Vx. So this is independent variable. So Y equals to V times X. This is straight line. It's from our geometry, and it's very simple to understand. Variable cost line can be mathematically expressed like this way. Okay, so Y equals to Vx. So this means when X is 0, Y is 0, right? So X, V times 0, Y is 0. So it means this line starts from original point. So let me see what we have here. Total variable costs change in direct proportion to change in volume. So, yeah, so when X increased by 1%, Y increased by 1%. And our X increased by 20%, Y increased by 20%. So basically, this means here, variable cost changes in direct proportion to changes volume. This is Y is the variable cost, X is the volume. The variable cost per unit of activities is V, remains constant, and is the slope of the variable cost line. So V is a constant value. It's the variable cost per unit of the activity, and it doesn't change. So this is basically, if you have this is slope. This is a slope of this line here. Slope is y divided by x. So here is the equation. So that's basically variable cost. Fixed cost, I think next one. Yeah, fixed cost. Fixed cost is means what? The cost does not change within a certain period of time. Total fixed costs stay constant over a wide range of volume. Fixed cost per unit of activity vary inversely with changes in volume. So the higher the volume, and the lower the fixed cost per unit, per unit of activity. So that means what? Say, student making the chairs. We have to have a place, we have a space. We need to have equipment. Let's assume we paid for space already. We don't need to pay for it. But need to pay for the equipment. And equipment we rent it. It's easy to do that. To do the calculation here, just say we rent those. So we rented 5 machines, and it costs us, say, $1,000 a month. And you're making $5 a chair as a cost, as a variable cost. So you're making 10,000 a month. Let's see, 1,000 a month. It's easier. 1,000 a month. So 5 times 1,000, your total variable cost will be 5,000, but you still have $1,000 fixed cost. That's you have to pay for the rent anyway. So now we have a 5,000. So we want to find a fixed cost per unit. $1,000 divided by 5,000 units is 20 cents, right? 1,000 divided by 5,000 is 20 cents per unit. But now if we increase our production and we increase to $10,000, 10,000 units a month, we still use the same equipment, means the same equipment will still pay $1,000 rent, but we're making 10,000 units out of this this equipment. So what is the fixed cost per unit here? It becomes 10,000 divided by 1,000. Sorry, 1,000 divided by 10,000 is 10 cents a piece. So remember, before this we have 20 cents a chair for the cost, and now we have 10 cents. So that means the higher the volume, from 5,000 to 10,000, and our cost per unit, fixed cost per unit, drops from 20 cents to 10 cents. So that's inversely change. Fixed cost per unit changes inversely in volumes. So here's basically this is what it means. And here's total cost. Graphs are always flat line with no slope that intersects the y-axis at a level equal to total fixed cost. So first thing, actually this one should be below this one because we need to know the equation first. The equation is y equals to f fixed costs. So from geometry, and y equals to constant, it's a straight line. So this is basically the fixed costs. So this is a straight line here. So this is y, this is x, and now y equals to 10,000. So basically y always equal to 10,000 no matter what volume it is. Okay, here is the fixed cost. Fixed cost is constant value. Alright, so basically fixed costs stay constant over a wide range of volumes. So let's do a recap. So we just talked about a variable cost and a fixed costs. Variable costs are the cost per unit does not change, but total cost variable cost would change along with the volume. So it goes the same direction, is a straight line. So in that one, it starts somewhere and then it's going to have a straight line as a variable cost. A fixed cost stays this constant. This is fixed. So what are the fixed costs in a company? So anything that does not change along with volume are considered as fixed costs. For example, the CEO's salary, a staff's salary, the salespeople's salary, and so on. Those are the variable. Those are fixed costs. Oh, okay, maybe those are indirect costs. So it doesn't matter whether it's indirect or direct. But basically, we're looking at something whether it changes through with the volume, something does not change with volume. We have the equipment as a fixed cost because depreciation, for example, we depreciate all this equipment anyways, no matter how many we have produced, and we're going to depreciate anyway. So those are the fixed costs. Okay, so let's go on. Cost decisions. There are in a fixed cost. There are two different types of fixed costs here. One's committed fixed cost. Those are fixed costs that the company is locked into the cost because of previous management. So those are the fixed costs being committed. And discretionary fixed costs such as the advertisement expenses. Those are results of annual management decisions, and also every year may be different. Even every month may be different because, but it's still a fixed cost. So because for this month we have spent this amount, and you're going to uh, uh, divide all these fixed costs and put those into the unit cost into the product anyway. So those are two different types of fixed costs here. Mixed cost, the mixed cost increase. So what are mixed costs? Mixed cost is the variable cost plus the fixed cost. So put together it's called a mixed cost. The mixed cost increase volume, increase as volume increase because the variable cost income component. And actually, everything will be more, will make more sense if we know how the total mixed cost will be expressed in mathematical way. So y as a total mixed cost equals to variable cost component is v times x plus the fixed cost component f. So y equals to vx plus f. This is a straight line. So this is a straight line, and if v is always positive, cost is always positive, f is always positive, so we're going to see a straight line, going up, always going up. And f is intersection, and so we're going to see here when x equals to 0, y equals to f. So we're going to have a line starts at f, y equals to f, x equal to 0, so basically 0 comma f point. So going up like that. So let's take a look here. So this will be the f, 8,000. So we're going to have a line starting from this point. So the point here, if you want to represent this on a coordinate, there'll be 0 as x, comma, 8,000. So this will be the point. It's 0, 8,000, 0, comma 8,000, and we're going to go up from here to here. So now the calculation of the slope will be a little different. So the calculation slope will be using this triangle here, or this triangle, doesn't matter. So we're going to use this one up to this point, because this triangle is here, divide by the value of here. This is x, so it's 4,000, and here this is 40,000 minus 8,000. So here it is. So that's why we have a delta y divided by x, or delta x. It's 4,000 minus 0. Okay, so we're going to do this a little in the next slide. So mixed cost per unit decrease as volume increase because of the fixed cost component. So this one's the same as this one. So total mixed cost are the same as mixed cost. So when the volume increase, x increase, they are all positive, and the y is going to go up. So let's see here. When the volume increases, as volume increase because sorry, this mixed cost per unit, sorry, y is the total mixed cost, so you need to divide by unit. So when x volume increases and this value increases and y does increase, and but using y divided by x, and that for the mixed cost per unit actually is going to drop. We're going to see some numbers we're going to find out, and it's pretty easy to find out in the way by finding the let's see, we have a $5 chair per chair as a cost, and then we have $1,000 as the total fixed cost for the month. And if we want to find a y here, total mixed cost, and then basically it's a 5, if it's a 5,000 shares, so 5,000 times a 5, so VX, $5, 5,000, 25,000 plus 1 is $26,000. So the total mixed cost, the mixed cost unit will be 26,000 divided by 5,000. So 26 divided by 5, it'll be 52. It'll be let's see, $5.2. Okay, it'll be $5.2 if we calculate that way. So now we increase our volume to 10,000. So actually, you just imagine, you can write it down. So from 5,000 to 10,000, still $5 per. The V here is $5. So 5 times 10,000, it'd be $50,000. But the fixed cost is still 10. So it'll be $50,000 plus $1,000, $51,000. And so now the total mixed cost will be $51,000. And so we want to calculate the mixed cost per unit. It'll be 51 divided by 10,000. So it becomes $5.1 per unit. So actually, we have increased our product, our volume from 5,000 to 10,000, but our mixed cost per unit drops from $5.2 to $5.1. So it makes sense here. So that's from calculation we can find it out. And you can find out this out by thinking that, so your variable cost, when it increase, is going to proportionally increase. And your fixed cost, when you increase, does not change. So the more you increase, and it means the one we have $1,000 will be divided by more in the volume. So the more you have the volume here, the lower you're going to have the fixed cost portion in the mixed cost. So that means you're going to have a decrease in the per unit cost. That basically is how we understand. So total mixed cost graph slope upward. So as we said, upward, but do not begin at the origin. They intersect the y-axis at the level of fixed cost. So this is the equation. Everything you can explain from the equation here. Y equals to Vx plus F. F is intersect. So intersection. So y, when x equals to 0, y equals to F. So it means on the axis, and there's this F here, and everything starts from F. So that's what we have in here. So this is F. F equals to 8,000. So we start from F, and then we just draw a line upward. So, and the slope will be used to the way to calculate slope. This guy here. The way to calculate slope is to use a triangle, either this one or this one, and use the y, delta y. Delta means this one, this y minus this y, so get this value. So this will be 24 minus 8 will be 16,000 for y, this section, and then this is x, 2,000. So actually 16 divided by 2 will be 8. So let's see, this is 2016. So it'll be 8 will be the slope. Okay, all right. That'd be 8. Yeah, here, right? Here, 8, which they have calculated here, $8 per gas. Okay. So here, this is the easy one. The following chart shows 3 different costs: cost A, cost B, cost 3. We want to find out which one is a fixed cost, which one is variable cost. So we just did the way to do is like this. So we're going to say, okay, cost per unit for the at 4,000 is 10, and we're having total cost. Total cost of 42, and then at 5,000, this is total cost. So total cost per unit. Let me see. Maybe, yeah, should be. So because total cost per unit changes, this one doesn't change. So in here, the increase in volume and the decrease in unit per cost, that basically this is a mixed cost. So so this is definitely what do I call? Identify each cost as fixed, variable, or mixed. So first one should be mixed here, and this one is when we add 4,000 units, we have a total cost of 46,000, and 5,000 units of production, we still have the same total cost. Means the cost doesn't change; it's fixed cost. So here, this is another one. So at 4,000, our cost per unit is 8, and at 5,000, and our unit per cost per unit is also $8. Means what? The cost is constant. Which cost has the so unit cost is a constant? Yes, it's a variable cost. So here's the answer. So first one is mixed cost, second one is fixed cost, 60, 60. And the third one is variable cost because this one does not change. Okay, so relevant range. Okay, I just do the readings on the book, so we're not going to spend time on this. We'll spend more time on the theory and concept. So let's take a look here. All right, there are other cost behavior, and this is not as as important as we just talked about. This is called a step cost. So at certain volumes, we are going to have certain level of cost. So these are basically fixed costs. So so at volume of number of children and a total cost, it's a total cost and a fixed cost. Total cost will be like this, at another level, at another level, another level. So this is total cost. Okay, this is it's very common that we have a per person at volume, and you're going to have certain total cost. But in here, this is a little bit uncommon, but it's still, you see this happens, and this is a step for at certain volume, and it's going to have a level of cost, and another level it's going to have another level of cost, and another level gets this. Okay, so this is another one. Curvilinear cost, so it's going up, it's still going up, but it's curved. It's curved. The trend's going up, but you don't have that as say a perfect line, and this is curved. And the same thing here, it's going up the curve. The more the volume it is, and the higher in general. And this is a little bit flat, and sometimes it even goes down. It goes down a little bit, and even more. But the trend is still going up. So still going up here. So we see the relationship is the more the volume it is, the higher the total cost. Okay. So this is in the chapters 20, exercise 20A. It's a back of book chapter. So this one's have you to find out all the necessary information from very limited information we have here. So this one is a Princeton dry cleaners has capacity to clean up to 5,000 garments per month. This is capacity. And complete the following schedule for the 3 volumes shown. So you may not have the full capacity. You only have had 2,000 garments in a month, or 35,000 garments in a month, and over 5,000 maximum. So the only thing we have here is total variable for this volume, 35, and the total variable cost will be $2,100, $2,100, and then fixed cost per garment is $2, and the total garments are 3,500. So first thing we can calculate is the total fixed cost. Total fixed cost is the fixed cost per unit times the number of units. So it'll be 7,000 here. So this will be 7,000, and we know fixed cost, it does not change. We can find 7,000 here, 7,000 here. So total cost will be 7 plus 2,100, it'll be 9,100 on this line. And then variable cost per garment, and so we have a 21 divided by 2,100 divided by 3,500, so it will be 0.6 in here. If you write it down, we can verify. And average cost per garment will be 0.6 plus 2, so 2.6 for this one. And so we find this, and we can find out the other ones. A variable cost does not change. So 0.6, 0.6. This will be 0.6. This will be 0.6. Fixed cost per garment does change because the volume changes. So this is not 2. This is not 2 at all. So we're going to see 0.6 times 2,000. We can find out it'll be $1,200 in here. So 2,000 times 0.6. We'll put 0.6 here. So 1,200 is 7,000, and that will be 8,200 in this line. And fixed cost will then be basically fixed cost is 7,000 divided by 2,000. It'll be 3.5 in here, and the total will be 3.5 plus 0.6. It will be 4.1. So it'll be 4.1. Same idea you can find it here. So answer is on the next slide. I'm pretty good. So I got all the numbers right. 7,000. These are all 7,000. So this put together 9,100. 0.6, 0.6 here, and this 4.1. Remember the last one we just have. So I'm not using a calculator. Okay, it's all in my mind. I just did a calculation, and so these are easy numbers. It's pretty easy to do. Okay, so just try to figure out this column. It's the same idea. If you can figure this out, you can tell, oh, I understand it. All right. So this continue. I've talked about this already. This is also in the book. I just do a reading because sustainability has been a very hard issue, and a lot of people have been talking about try to be responsible to the society at a time when you are making profit. So one of the sustainability is to use less paper. So we have e-banking, e-billing without having to use paper, draft and variable cost, and so on. So this pretty easy and straightforward. So next one is object number 3. Use account analysis and a scatter plot to analyze cost behavior. Okay, here we're going to find out how do we do the analysis. Very simple analysis. Excel will be your friend. It'll be a very good friend for you to do all these. 4 methods to analyze cost behavior. These are the most commonly used for. We may have more, but now it should be good. Account analysis, scatter plot, high-low method, regression analysis. Account analysis is the use of a judgment to classify each general ledger account as variable, fixed, or mixed. This is pretty subjective. Different companies may have different ways to categorize their own variable costs, fixed costs, and mixed costs, but mainly they are pretty similar because these are managerial accounting analysis, and there's not a there's some principles, but this is not like generally accepted accounting principle GAAP, and so we don't have GAAP for this. So basically, companies, they can do whatever they want to do the analysis. So it's pretty subjective, okay, in here. All right, so we're going to look at here, scatter point. So scatter plots. We use historical data to determine a cost behavior. And when we try to determine cost behavior, we always historical data. So we use the last 5 years, last 5 months, or usually 5 months or 10 months, and find out the behavior of the cost. So it means behavior here is to try to see, are we having how does the volume change affects the cost in our company? And our company may grow from a very small one to a large one, and you want to take a look at how cost has been reduced, or are we reducing as much as we can? Scatter plot is the graph of historical data on the y-axis and volume data on the x-axis. It helps manager visually determine how strong the relationship is between the cost and the volume of the chosen activity base. So here it is. So at certain volume, we have certain cost. So you see here it's not a very straight line, but it's basically it's a pretty straight line here. So this you scatter every time you have a value for the volume, you get a total cost, and I get a total cost here, and volume here, and just put those numbers into this graph, and you find out, and this is a trend. So the more the volume it is, the higher the cost. So this will be total utility cost. So utility cost increase as the volume increases. So this is another one. It's a high-low method to analyze cost behavior, and lazy guys do this. It's not always a very good one, but sometimes it works well. But in most cases, you don't know. Let's see how it works. There are 3 steps. Find a variable cost per unit, the slope of the cost line. Find a fixed cost, and then create a cost equation. So it's easy to use, but only use 2 data points. So for example, we have the volumes of the cost for I think a vehicle drive, and here the high-low method, the cost equation for van operating cost. Yeah, so we're going to find out at the volume of 16,000 miles, how much the van operating cost will be. So this one is going to find the lowest on the y and the highest in the y. So y is here. The cost is always a y-axis, and this is our x. So we're going to see the lowest ones are 49.20. And so we have one coordinate and a point on this on the system here. So it'll be, this is x, this is y, 14,500, and y equals to 4,920. So this is 1 point. And then we find the largest one, 5820. So, and then the total miles volume will be 16,900. So 16,900, so this will be another point. So we plot these 2 points on the coordinating system, and then we link that, we get a straight line. So let's see what we have here. Oh, didn't draw a line here. Okay, so this is a coordinate. I cannot draw here. This is a coordinate, and then it'll be 4920. This is a 1450. Let's assume 1450 is here. 14,500 is here, and then 4,920 is here. So we get let's put it here, a point here, and then we're going to find another line, another one, and it's here, 16,900. So let's assume 16,900 is here. It's larger, it's on the right side, and then it's a 5820 20. Let's assume it's here. So we just link this line and extend it to y, and we have a straight line. So to calculate the slope is to find the y-axis and x-axis. You can basically do here, and x-axis, and then you get the total. And using y divided by x, then you get the slope. Okay, that's basically what we do to find a slope. Let's see. Actually, this one does not really get direct y-axis here, and so this line does not start from the original point. So there'll be a fixed cost in here. So basically, we can find a line. So find the slope of the mixed cost line. We have 2 points now, right? We have 1 point here, this lower one. The high point here is another one. To find the slope is so we have one here, so from here to here. So this is our triangle. Even though our coordination system here, but you can find a triangle here. And the slope it is at this angle here. So you extend this one to intersect with y and do this. These two are parallel. So basically you can find the slope using these 2 points. So first point is this one, 14,500 and 4,900. So it will be 1 point here. And then there's another one. It will be 16,900 and 58, y equals to 5,800, 5,820. So we have here. So we have a triangle. So what is it? This the value of this. This is this y minus this y. So it'll be 5,820 minus 4,920. It'll be 90. So this will be y equals 90. This is the delta y is the difference between the high one and the lower one. And what about x here? This is about delta x. There will be a x in here minus x in here. So 16,900 minus 14,500. So it'll be 22. Is that right? 2,200. So this will be 9. 2,200. Will be 9 divided by 2,200. So it's not easy to calculate. I don't have the calculator with me, but you see how we do that. So in here, this is a step 1 to find the slope of the mixed cost line. It's a delta in cost y divided by delta in volume. So that's how basically we just talk about in the coordinating system, and we find out the triangle, and then we know the slope is to use in a triangle this, and then this value divided by another this side value of this side. So then we get the slope. So before in the slope, the slope represents the variable. Oh, they do have this one. So it's 910. 4910, is it right? Let me see here. 4920. Huh? That's weird. So 5820, 4920. 5820, 49. Haha. All right. There is a mistake here. But anyway, it doesn't really matter. 16,900. 14,900? Why is that right? Okay, it's 14,500. Oh, I was wrong. The lower ones are 4910. It's not a 5920. So actually, it's a 4910 or 4920. From that 4920. So I apologize. This is the lowest point, and this is highest point. So that makes sense. So here we get the slope is 0.455. So we get a point here. And I'll try to draw a line by itself. So let's just follow my cursor here. This is a y, this is x. So this is x here, it's a straight. And then you're going to find out, just find out points, just assume this is 14,900. And this point at D here, it's the 4910. So y equals to 4910. And then in the x here, you're going to go find out 16,900. And then you're going to have, let's assume it's here. This point is the 5820. So with a D, right? So you're going to link this line, make this section. You can extend this to intersect with y. So now you're going to draw a line from this point down to here, and draw a line from here to here. So now we have a triangle. So triangle this line, and this line. So what we do is this is a delta in cost y, and this delta in volume x. Delta in cost y. So delta here, delta in volume x, this line. So basically you can find the slope using this way. So this is 49, this is 0.455. In step 2, find a vertical intercept. So vertical intercept is a fixed cost minus the total mixed cost minus the total variable cost. So the way to find out, okay, remember we have a triangle here. The top here is a 5820. This is on this line. This line is the variable cost line. No, the total. Let's see. Yeah, including this one. This is a total fixed cost line. This is above the. Sorry, total mixed cost line is about a fixed cost. So you're going to have this point is a total mixed cost at 5820, and you're going to use to minus whatever variable cost it is. So on this one, we have a x point is a 6,900. So to find out the variable cost is to use a 16,900 times whatever slope it is. Slope is the variable cost per unit. So this will be the variable cost. So you can do total mixed minus total variable cost. Then we get a total fixed cost. Total fixed cost is the intersection. Is the intercept, sorry, not intersection. Intercept is the vertical intercept. So we find here, and then we can get our equation. Y equals to 0.45, should be x here, plus 1,869.5. So it's missing x here. So let's see, times x. Okay, that should be it. Apologize. These are provided by the capital X here. By the publisher. I didn't notice they have made so many mistakes. Okay, so this is how we've used the high-low method. It's all about the geometry actually. When we find this equation, and we immediately have a line. But if we don't have the equation, but if we have the line, we can always find the equation through the steps we have discussed and it's described here. Okay, try to do it yourself and see if you can do this without any problem. It's important because this is what we do in this chapter. The last one is to use regression analysis. Regression is a statistical method, and here is used to use the Excel. So we are not going to discuss too much in this here. You may have learned how to do the regression already. There'll be a function to the regression study. The book has some description on regression analysis. Um, let's see here. Do we have that? Yeah, the book has some discussions to regression analysis. It's not a very simple math to use here, so I don't think you're required to do regression from scratch in this class. So basically, you're going to learn statistics, business statistics. Later, you're going to understand what regression is about. So just keep in mind, regression analysis is a much better way and a much more common way a company may be using to find a trend in the cost behavior. All right. So R-square values, um, R-square values is also in the statistics. We're not going to do too much on this one. It tells whether how well a variable has been explained. Okay, what does that mean? When you do the statistics, you understand what this means. But R-square is a very important value here for the regression. It tells how well the line fits the data. Okay, so we're not going to spend much time on this one. If you're interested, do a Google, find a statistics book. You're going to find to see what R-square means. But R-square always come from the regression. So you need to know the regression and then do this. If you don't know how to do regression, okay, don't worry. You're going to learn that in another class. Data concerns. So this will be some more informative. Data concerns are on the data are only valid within the relevant range. So remember we have a relevant range here. Some data here for the volume here, and so 20,000 is only valid when the volume is below certain. 40,000 is only valid between this one. So validity of the data, it depends on, let's see here, depends on the range of the volume. So that could be a concern here. Seasonal variations and companies when they're making sales, and so the best time of sales may be the Christmas time. And the other time they may be very slow and they don't have a lot of sales. And so same thing that will be affecting the company. That when there is not many sales in the stores, they're not going to be making a lot of product. That means fixed costs will play a big role in the cost of the items or products. So seasonal variation may have a big impact on the cost. Inflation, that's how everything gets more expensive. So inflation exists all the time. We're experiencing inflation. Actually had a very big inflation in the gas price. I just came back from Texas a few days ago. Um, the price there is much cheaper than the gas price is much cheaper actually. In the Chevron, the unleaded gas only $1.55 in the town where I went to, and where we're paying for 2.30 2.40 a gallon here. So price changes and the price is going up, and inflation is how we describe that. Outlier, it's interesting. When you do the plotting, and sometimes you may have a point, it does not fit into this trend at all. This is called outlier. Outlier exists. Let's take a look here. Do we have outlier? Actually, the book does have the outlier. I don't have it on here. And so you may want to, when you have seen the outlier, you may want to take it out and so that your model will fit to the most of the points on a scattered plot. Okay, here's the where is it? Okay, object number 6 is to look at the variable costing and the prepare control contribution margin income statement. So we're not going to really do the income statement in this class here. You can do the book has a very brief ones on the income statement. It's very simple. It's part of the financial accounting. And what we want to do here is to look at variable costing and traditional what's that called, absorption costing. Absorption costing is required by the GAAP and IRS, and so it assigns all manufacturing costs to products, direct material, direct labor, variable manufacturing overhead, and a fixed manufacturing overhead all into the what's that? The inventorable cost, inventorable product. So that basically is the absorption costing. But a lot of people does not agree upon this one when they're doing internal accounting and manager accounting. They find that some fixed costs, they're more about how the capacity of the company. It's more related to capacity of the company, and they cannot be treated as inventorable product cost. So so even though when they are reporting to external parties, they are using the absorption costing, and they're also using the variable costing because they try to treat the fixed manufacturing cost, fixed cost is in a different way, because in that way they can manage their production and cost in budgeting in a much efficient way. So it's more basically for the internal management decision, and so we're not going to take a look at this one here. So reconciliation. What is the reconciliation? Reconciliation is try to compare the values on one side to another side, and so here's the differences in operating income equals the changes in inventory level in units times fixed manufacturing overhead per unit. And so here actually there are some comparison of variable costing and contribution marginal incomes. This is basically absorption costing. So they have some differences as we have described here. Just some for your information, you want to take a look here as what we have described before this chapter before we talk about the variable cost and the fixed costing, and then basically they were the traditional one, absorption costing. But for many companies nowadays, we are using variable costing for internal use and internal decision use. So here is an example in the book. I think we are getting to an hour. I'm not going to do that one in here, and this slide it's a pretty simple one. Inventory increases, absorption cost income is higher than variable cost income. Why? So think about what are included in the absorption costing here and what are not included in the variable cost. So absorption cost has a lot more than variable costing. Absorption costing does have the fixed cost in here. A variable costing does not have them. Okay, so you're going to see when the inventory increases, their income is higher than variable. So you're going to see the values because absorption is much higher than then variable. So that's basically that what means here. So the other ones are very straightforward, and to do the readings in the chapter, you can find out those why. And that's basically the end of chapter. So we'll finish that within an hour. Yeah. All right. We're going to talk about chapter 7 tomorrow. See you later.